So why is it that we sleep? There are lots of theories, and we'll be discussing a few of them here. Sleep is not actually a passive process that takes place as a result of a decrease in sensory stimulation. Sensory deprivation research has shown that people actually sleep less, not more, when they're placed in isolated environments. So this is contrary to what would expect. So it's not that sleep is trying to balance your daily periods of activity. Generally, sleep is thought of as a biological adaptation. Sleep is an energy conserving strategy, so we tend to gather food at optimal times and sleep to conserve energy for the rest of the time. Animals with nutrient-rich diets spend less time foraging for food and more time sleeping. So again, it would be adaptive for us to sleep at certain periods of the day to conserve energy, and during the rest of the time when it would be most adaptive for us to do so, then we would go out and gather food. Animals that are predators sleep more than animals that are prey. Animals that are prey tend to be lower on the food chain, and you would actually need to spend more time gathering and more time trying to get all the nutrients that you need, whereas animals that are predators are a little bit higher up on the food chain, so it's more important for them to conserve energy because it also takes more energy when they actually try to prey on the smaller animals. Nocturnal or diurnal animals will also sleep during the times in which they cannot travel easily. So humans cannot see well at night, so again, it's also not advantageous for us to try to engage in hunting or gathering activities during that time. Sleep is also a restorative process. We have certain chemical events that provide energy to cells. This may be reduced during waking, and this may be replenished during sleep. So while we're awake, our cells might be trying to be active to help us engage in all of the activities that we need to engage in during our waking hours. During sleep, then this basically allows a time for our cells to repair and replenish themselves. So this theory is supported by studies examining the effects of sleep deprivation, and that when we don't sleep, that this can have negative effects on our body because our cells basically don't have the time or the ability to replenish themselves. Sleep deprivation is quite interesting because there are no marked physiological effects. This has actually been tested up to 18 days under low, no stress conditions. But they tend to be very drastic changes in brain and cardiovascular effects when combined sleep deprivation and stress. So when we think of sleep deprivation, most of the time sleep deprivation occurs in the context of stress. So when sleep deprivation occurs when there is no stress, one, that would be really quite rare, and there would be no adaptive reason or really almost logical reason for that to happen aside from basic curiosity. Let's just see how long we can stay up. But most of the time when we are sleep deprived, it occurs in context of high stress. And when this combination occurs, then this can have very, very extreme effects on our body. Sleep deprivation can lead to decreased cognitive performance on tasks that require attention and decline as a function of hours of sleep deprivation. So most of you are familiar with the basic effects of sleep deprivation. It's most specifically talked about in terms of driving, about how dangerous it is to drive in a sleep-deprived state. One of the primary reasons for this is that in a sleep-deprived state, what happens is that you have something called microsleep. And microsleep is a brief period of sleep lasting a second or so. And during this microsleep, that of course is when you can fall asleep briefly, and especially if you're driving or engaging in any other complex activity that requires attention, then you would lose that attention and you can hit other people or stray from the road or so on and so forth. Another important theory behind why we sleep is the role of sleep in memory storage. It's postulated that sleep plays a role in solidifying and organizing events in memory. There's a process of consolidation, which is the process of stabilizing a memory trace after learning. And this may involve moving, quote unquote, a memory from initial coding site in one part of the brain to a permanent location in another part of the brain. You also have reconsolidation, the process of restabilizing a memory trace after the memory is retrieved or revisited. So both consolidation and reconsolidation have been implicated in sleep. Episodic explicit memory consolidation is postulated to occur within non-REM sleep, while implicit memory consolidation is postulated to occur within REM sleep. While the process of shifting a memory to a new location during consolidation is postulated to occur during sleep, reconsolidation is actually an ongoing process during both waking and sleeping, and it can also involve daydreaming and night dreaming. So while we are forming long-term memories, or we're in the process of moving something from short-term memory to long-term memory, we're going to think about it at occasional times throughout the day, as well as while we're sleeping.